Hello and welcome to today's mathematics class. For this class, we'll consider the study of permutation. So we'll look at the study of permutation ranging from the definition, its mathematical expression, and some several problems, right? And also look at the application of this permutation, right? Where possibly can we also actually apply permutation? So we'll look at those concepts one after the other. Here is the definition. Permutation can be defined as the arrangement of n different objects taking R at a time. From definition, quote the word arrangement, please. Whenever you hear the word arrangement, that arrangement has to do with what? Combination. So here is the task. Whenever you're given a question, to differentiate if that question is a combination question or permutation, when you hear the word arrangement, that is what? Permutation. So note that permutation is basically how to arrange n different objects taking R at a time. That becomes your definition. So how do you possibly arrange n different objects and taking R at a time? Note that permutation is abbreviated by P. We use P to abbreviate permutation. So P is used to represent permutation. So I'm saying that given an n different object taking R at a time, this becomes n factorial over n minus R factorial. If I'm given n different objects taking R at a time, it becomes what? N factorial all over n minus R factorial. This becomes your mathematical expression for permutation. So it becomes your mathematical expression for permutation. At this point, note that n, the value of n is always greater than what? R. Very important that the value of n is always bigger than R. What do I mean? If I have 6 permutation 2, this is correct, it makes sense. But if I have 2 permutation 6, this is wrong, please. The value of n here, it must be bigger than what? Than R. So that becomes your concept. All right, at this point now, let's look at what's it called? All right, at this point now, having discussed about the mathematical expression and n being greater than R, let's look at something called factorial. As you can see from the mathematical expression, I'm saying factorial. What is factorial by definition? Let's look at the concept of factorial. Exclamation mark. From the word, from English, we call this exclamation mark. But let's look at the definition, please. What's a factorial by definition? A factorial is simply the multiplication of consecutive terms in descending order such that each term differs from the previous by 1 until 1. So I'm saying that factorial is simply the multiplication of consecutive terms in descending order such that each term differs from the previous by 1 until 1. That's your definition for factorial. All right, I understand the definition of factorial. What does it mean? Look up. Let's start an example. If I have a 5 factorial, what does it mean? It means 5 times 4 times 3 times 2 times 1. Let's say I have 4 factorial. This means 4 times 3 times 2 times 1. 3 factorial gives 3 times 2 times 1. Next up, let's do 2 factorial. That's 2 times 1. Let's do 1 factorial. That's 1 times 1. 0 factorial. Please note that 0 factorial is what? Is just 1. This becomes your idea of factorial. The multiplication of what? Consecutive term in what? Descending. This is 5, 4, 3, 2, 1. In descending order, such that each term differs from the previous by 1. 5 minus 4 is 1. 4 minus 3 is 1. 2 minus 1 is 1. Observe. 4 minus 3 is 1. 2 minus 3 minus 2 is 1. 2 minus 1 is 1. So that such that each consecutive terms differ from the previous by 1 until 1. Observe, until 1, until 1. So I have this place. So note that 5 factorial is simply 5 downward to 1. 4 factorial is what? 4 downward. So if I'm saying 10 factorial, I mean what? 10 times, 9 times, 8 times, 7 times, till 1. That becomes a concept of factorial. At this point now, note one relationship, please. Note this relationship. Note this relationship. Look at 5 factorial for God's sake. Look at 5 factorial. I have 5 factorial has been equal to, listen up, oh. Listen up. Observe that 4 factorial contain 4, 3, 2, 1. But see yet, 4, 3, 2, 1 exists in 5 factorial. So I can see that 5 factorial now is equal to 5 times what? 4 factorial. True. From here to here is what is here. What's the value factorial? That's it. See, correct this way. Similarly, if I have 4 factorial, this becomes what? 4 times 3 factorial. Why? Look up. Look at your 4 factorial. This 3, 3, 2, 1 exists in 4 factorial 3, 2, 1. Replace this as what? As this value. So I have this. Right? This becomes your relationship between factorial. So similarly, if I have 3 factorial, that becomes what? 3 times 2 factorial. And it's continuing in this pattern, please. So note this relationship, very important in the study of permutation. All right, I understand factorial. Let's now move back to our concept of permutation. So at this point now, at this junction, let's try to take some problems and let's solve together, please. Just an example, please. Example 1. The one says, evaluate the following permutation, please. Evaluate the following permutation. Number 1 there, I have 8 permutation 3. Sorry. B, I have 9 permutation 4. And C, I have 7 permutation 2 plus 9 permutation 2. So I have this. So let's try to evaluate this particular problem and let's see what we get, please. Listen up, listen up, listen up. I'll do A for you and I'll do C. You do B and put your answer in the comment section below. I'll reply you as fast as I can. Let's do A, please. Solution. For my A there, I have 8 permutation 3, right? That's all. Check, go back to your original expression for permutation. We said if I have n permutation r is equal to what? N factorial over n minus r factorial. What does it mean? From here now, it becomes, what's your n? N now is 8. It becomes what? 8 factorial all over what there? We said n minus r. So my r is this down number here. That becomes 8 minus 3 factorial. What do we get from here? It becomes 8 factorial over 8 minus 3 is what there? 5 factorial. So this becomes my, I can't this is my answer. No. I have to simplify this. Observe that if I want to expand 8 factorial using relationship, I can get 5 factorial in 8 factorial. So to save my time, I can just say 8 times 7 times 6 times 5 factorial all over what there? 5 factorial. Right? This one cancel this. If I multiply 8 by 7 by 6, that's 3 something. 8 times 7 times 6, that's 336. 336 has been my answer. If I want to again, 8 factorial divided by 5 factorial is easy using my calculator. Go back to calculator this way. Are you there? So click on 8. I see my 8 here. See the 8 here. After clicking on 8, what your next task? Look up 8 factorial B. Check. Go back to calculator. Look for any symbol that has factorial Look at this. This one has a factorial symbol. You can see. So if I click on shift and that symbol, see 8 factorial. Press an equal to. I have 40320. So for 8 lookup, another way to get my answer, or 8 factorial gives what there? 40320 all over 5 factorial is what? Check, go back, chief. 5, this 5 here, then shift that symbol, 5 factorial, right? Click on it, that's 120. That's 120. Please divide the two. What do we get? 40320 divided by 120. I have 336. 336. The same answer as this, depending on your choice. Right? If you want to use calculator, go straight to calculator and get your answer. If you want to use normal approach, then you're good. So I have this. So you do try doing B, do B for me, and put your answer in the comment section. Let's do C. For C, I have 7 permutation 2 plus 9 permutation 2. How do we express this? Perhaps, how do we solve this? It's quite simple task. What do we know here? This becomes 7 factorial all over 7 minus 2 factorial plus this becomes 9 factorial all over 9 minus 2 factorial. What do I get from here? It becomes 7 factorial over what there? 5 factorial. Am I correct? Plus it becomes 9 factorial over 7 factorial. So I have this as my answer here. Sorry, as my expression per se. At this point now, what's next task? I can't start saying 7 factorial is 7 times, 6 times. I'll waste my time. So what do I do then? What do I do now? I'll just take my calculator and punch 7 factorial the way I showed you earlier. I had 5040 all over 5 factorial gave me earlier. I had what? 120 plus what's 9 factorial? Press 9 shift that symbol that has factorial. That's 362880 all over what's 7 factorial? That's 5040. Divide this one first. 5040 divided by 120. I have about 42 plus 362880 divided by 5040 there. I have 72. Add them up, please. I'll have 4 here. 11. 144. So my answer here becomes 144. And if you want to, you can punch this directly on calculator. You have your answer, please. Let me show you, please. Look at it. I have 7. Look at permutation is here. Shift this point here is permutation. You can see this symbol permutation here, right? So press 7, then shift that symbol that has permutation. Then what's next? 2, Abby. This is my 2 plus next up 9 shift permutation. What there? 2. What do I have there? 144. Of course, I have 144. Please so observe 144, right? 144, right? So I have 144 here too. It becomes how to evaluate this particular problem. Let's look at the next case study under permutation called the algebra of permutation. Welcome back. Let's look at the concept of algebra of permutation. By the word algebra of permutation, we mean how to find the value of n in a given permutation question. We'll take some few past questions and some problems, look at those past questions and problems together. We'll look at how to possibly evaluate problems under the algebra of permutation. A very quick one. Example. Example 1 under this. If I have I'm going to find the value of n, find the value of n in the following. All right, For A there, I have n permutation 2 being equal to 12. For B there, I have n permutation 3 being equal to 120. And let's take one more. C, I have n permutation 4 being equal to 12 times n permutation 2. All right, let's get this done, please. All right, let's get this done, please. Now it says find the value of n, right, in the following. So I have this. So it becomes your task under the algebra of permutation, right? So let's get this done, please. Solution. How do we solve this? Solution. Number one there, I have for A, I have n permutation 2 being equal to 12. Note something, please. Note this thing. I should have given you earlier before now, but note that if I have n factorial, the value for n factorial is equals to n into n minus 1 into n minus 2 into n minus 3. It's continuous. So note that n factorial is equal to that n into that same n minus 1 into that same n minus 2 into that same n minus 3, and it continues n minus 4, n minus 5. Just note that anywhere you are stopping, put factorial at the back of it. So I want to solve at 3 now. I have to put factorial at the back of it. So n factorial can be anything. You can stop at any point. Just know that you start with n into what there, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. It continues until you reach your destination where you want to stop. And mind you, anywhere you stop, put what? A factorial symbol at the back. Know this, know this task, please. Very important. Know this, man. Let's solve this, please. From our concept of permutation, we said if I have n permutation r, this is equal to what? N factorial over what? N minus r factorial. True. Apply this technique here. This becomes n factorial over n minus, my r here is 2 factorial. I have this being equal to 12. All right, at this point now, how do we get this done? Observe that my denominator is n minus 2 factorial. This is n factorial here, and you know that I can expand n factorial till what? Till this 2, right? So at this point now, I will replace n factorial, but at this point now, n factorial was, we said, can be either n into n minus 1, n minus 2, and continues. But I'll stop at this point and put factorial here because my denominator stop at n minus 2. So I'll stop at what? N minus 2 here. So I'll replace n factorial as being equal to this value. So n factorial now will be equal to n into n minus 1, n minus 2 factorial all over n factorial. I have n minus 2 factorial being equal to what? 12. I have 12 here. This man cancel this. That's our aim and target, right? So have my answer as being equal to what? N into n minus 1 being equal to what? 12. So this is what I'm left with. So at this point, observe that I'm having 2n, n and n. What does it mean? It means that I'll be having 2 values of n. That's the meaning. How do you get the 2 values? This is 12 here. Listen up, oh. This is 12. Look for, since my n is 2 here, it means that I'll look for 2 numbers that if I multiply together, it will give me 12. And their difference should be 1. Like, okay, for instance now, this becomes n into n minus 1 equal to 4 times 3. Observe that 4 times 3 will give 12. 4 minus 3 will give 1. That's the concept. Since my n is 2, if my n value, this n are 2, I'm not saying only 2n here. It means that I'll look for 2 numbers that, if I multiply them together, it will give me 12. If I subtract them from each other, it will give me 1. That's this here. Please. If n is 3 here now, I'll look for 3 numbers that I'll multiply to give 12. But by the way, now, at this point now, this becomes my expression here. This n this n now, this one will be equal to what? This first term 4, comma, this one in brackets n minus 1 equal to what? This 3. N is equal to this 3. This one becomes plus 1, n equal to 4. What does it mean? It means that my n, therefore, n is what? Is 4. So it means that if I put 4 here, if I now press 4 permutation 2, I'll have 12 as my answer. You can try that and check if it's correct. You can try that. So my answer for number 1 becomes 4. So I have this. Let's do number 2. For B, I have n permutation 3 being equal to 120. The same tax. It becomes n factorial over n minus 3 factorial equal to 120. I'll try to expand this in this form, right? In this form, so that this one now we cancel this down one. That's the concept. That's it. So what do I get there? Okay, I can even use what is up here. I can use this value, right? Instead of killing the board, I can use that value. So at this point now, you now say but n factorial is what in this expression? Why did I stop here? Because this down one stop at that same point. So I'll stop at that same point so that they can cancel out. So for me now, this n factorial now becomes everything here. So that becomes n into n minus 1, n minus 2, n minus 3 factorial all over this man here becomes n minus 3 factorial being equal to what there? 120. This man will cancel this. What do I get? I'm left with what? N into n minus 1, n minus 2 being equal to what? 120. What does it mean? I said earlier that if I have 2n, I'll simplify this in 2 ways that I'll multiply together to give me 12. This is 1, 2, 3, 3n. So look for 3 numbers that if I multiply them together, it will give me 120. And their difference is just 1, 1. It becomes n into n minus 1, n minus 2 equal to what? 6 times 5 times 4. This one will be 120, please. 120, right? So 6 minus 5 is 1. 5 minus 4 is 1. Correct. Correct, please. So this n goes with 6, as we did earlier. This n goes with 4. This one now goes with what? 3. So I have this n goes with what? 6. Or this n minus 1 goes with what? 5. Or this n minus 2 goes with what? 4. This becomes n equal to 5 plus 1, n is 6. Or n is equal to 4 plus 2, n is still 6. Therefore, n equal to what? 6. This is my answer. So this becomes how to solve this particular problem. So if I put 6 here, it means that if I punch 6 with permutation 3, I'll have 120 as my answer. So it becomes how to solve this problem here. Let's do the last one and we'll end the concept of algebra or permutation. We'll look into the applications of permutation. All right, let's get this done, please. All right, let's do question C, our half, please. I'm having n permutation 4 being equal to 12 times n permutation 2. All right, is this 12 or 2? This man 12 or 2? All right, it's 12. Is correct, please. Let's get this done, please. So similarly, same concept to work here. So I have n factorial over n minus 4 factorial is equal to 12 times, this one becomes n factorial over n minus 2 factorial. I'm off. I expand this one in terms of this. N into n minus 1, n minus 2, n minus 3, n minus 4 factorial. All over what? This man, n minus 4 factorial, is equal to what? 12 times. Observe, please. This one becomes n into n minus 1, n minus 2 factorial all over what there? N minus 2 factorial. But now you should understand why I'm stopping at this point. Why I stop at this point? So that what? They can cancel out. They can what? Cancel out. What am I left with? I'm having n into n minus 1, n minus 2, n minus 3 equal to what there? 12 times n into n minus 1 into, sorry, n minus 1. That's all, please. So I have this left. So how do I simplify this? In mathematics, listen up, please. Learn this technique in mathematics. If I'm having two things being present in two sides of equation, they cancel out. What do I mean? If I have AB cube equal to CAD, look at A and A occur, they can cancel out. That's math. What do I mean now? Observe this one here, we cancel this. I'm having, so I have this one here. So I'm left with what? N minus 2 into n minus 3 equal to what? 12. This is 12. This is how many n? 1 to 2n. Look for two numbers. That's 1 and 3. So I have n minus 2 into n minus 3 equal to 4 times 3. Two numbers. I'm having 2n for two numbers. So I have what? N minus 2 equal to 4 or n minus 3 equal to what? 3. Plug this one with this 3. Plug this one with this 4. What do I get here? N equal to what? 4 plus 2. N is what? 6. Or n equal to what? 3 plus 3. N equal to what there? 6. So my answer is 6. What does it mean? If I put 6 here and put 6 here, right? If I put 6 here, 6 permutation 4. Let me see. 6 permutation 4 will give 360. So this one will give what? 360 equal to, this one too must give 360. Put 6 here, that becomes 6 permutation 2 is 30. 30 times 12, that's 360. So it's 360. So it's correct. It's equal to, it's correct. So I have this as being my answer after solving that particular problem, as you can see. All right, this becomes your idea behind algebra or permutation. Let's look at one last topic. One last concept called the application of permutation, and we're off.